Today we are talking about what are called algebraic limits. Today, at the end of class, you should be able to find a limit without a graph or without a table on certain functions. You're going to learn half the lesson today. The other half you will go home tonight and watch the video to learn it. So, let's start with the notes right here. Oops, if I can hold a pen properly. We're going to title these algebraic limits. And like I said, tonight's notes from the video, you're just going to add on to these. I'm going to stop these notes where the second video starts. Okay?
And so when we do the video notes,
just add them onto these.
So just write down what.
Yeah, it's going to be just like this, like you were sitting in my class, but you're going to be by yourself and write it down. Yes. Okay. So, please write the following sentence down. The easiest way to find limits algebraically. ... And I'm about to tell you what that is. Like I said, I'm going to give you an equation and you're going to algebraically find out what the limit is. Now, do me a favor, turn in your notes back to yesterday's notes real quickly. Look at the definition of limit I gave you right at the beginning. What is the first word in the definition that I gave you? A. What else after that?
Y.
That's not a word?
Value.
Thank you. Y value. So a limit is a Y value that a graph approaches. Now, if both sides approach a Y value, is that Y value going to be the limit? Think about it. If two sides of a graph approach a dot, is that dot going to be the Y value? Going to be the limit. I said that wrong. Yes, that dot will be the limit. So, limits and Y values most of the time are the same. So, if I give you an equation and I asked you to find its limit, all you really have to do is find its Y value. How do you find the Y value of a function if I gave you the X? You plug it in. So, the mathematical term for plug it in is direct substitution. So this is the quickest and easiest way, if you can, to find a limit. So, for example, the limit as x approaches 2 of 2x minus 3. The limit as x approaches 2 of 2x minus 3. Okay. Can you substitute this limit value into that function and get an answer? Yes, you can. That's what you do. 2 times 2 minus 3 equals 1. That's your limit. You're done. Wow. God, that was hard. Did all that work. Okay, the ones we did yesterday were harder than this. Okay? That was just too easy. Okay. But I'm trying to show you this. If you can plug it in, that's the answer. Okay? Now, let's think about this graphically. What kind of equation is 2x minus 3? Linear, right. Does every point on a linear graph have the same? Do they approach the same point? Yeah. And isn't that point the Y value there? Yeah, so that's why the limit happens to be the Y value. That's why I plugged it in. Okay? Next problem. The limit as x approaches 3 of sine parentheses pi x divided by 2 equals. Can I substitute the 3 in there and get something that I should be able to solve if I remember my trig? Yes. So write sine. What should I write? Sine of what? 3 pi over 2. Now, without saying a word, real quickly, raise your hand if you know what the sine of 3 pi over 2 is. Don't say it. Just usually I got a 2 or 3 in a class. Oh, wow, more than this time. Okay, put your hands down. How many of you in here know where 3 pi over 2 is on the circle? You know where 3 pi over 2 is? That's better. Okay. So let's look at the circle. Where's 3 pi over 2? At the bottom. Is sine x or y? What's the Y value right there? -1. There's your answer. Okay? If you did not memorize the unit circle last year, you need to start looking at it. If you watch the video, I've got some really good tricks on how to memorize it. Okay? I know that in regular pre-cal they did not make you do that. In pre-AP they did. Okay? Next problem. The limit as x approaches negative 4 of the square root of 5 minus x. Can I substitute negative 4 in there and get a real number answer? Okay, it will be 3. Okay? 5 minus negative 4, which becomes plus plus, which becomes the square root of 9, which is 3. Now, if you come out with something like the square root of negative 2, then that's a does not exist because it has an I in it. So, box that in. Example, one more. Limit x approaches 1 of that. Arc cosine. Ooh. How many of you kind of remember seeing that last year? Oh, okay, good. I'm happy about that. Some of you may have seen it this way. Cosine inverse of x. Did you see that? Yes. Okay. That's the same thing, by the way. So, when you substitute the number in, let me show you how you do it. This is the cosine inverse of 1. It is the inverse of what we did on the second example. Okay. On the second example, I gave you an angle, and you gave me its y value because it said sine. So you start with the angle, you get the y value. This means I want to know the angle that has an x value of 1. So I'm giving you the x value. What's the angle? Where on here? Right there? Okay. I don't want to do 2 pi. I want to do the simplest answer possible. 0. That angle is 0. Remember, we're doing radians, not degrees. Now, in this case, it doesn't matter. But it's 0. The angle, that's the angle where the cosine or the x-coordinate is 1. So here I gave you the angle, you gave me the y-coordinate. Here I'm giving you the x-coordinate, you tell me the angle. It's backwards, like Jeopardy. Okay? That's what arc cosine or cosine inverse is. All right? Any questions? So, we have just learned that if you can, you plug in the number, that gives you the limit. Quickest way to do it. Okay? Now we're going to talk about piecewise functions. What do we do? Because in piecewise functions, you can still plug it in, but sometimes it's kind of hard to tell where. So for piecewise functions, comma, look at the LHL and RHL. Oh, we just talked about that. Do you remember what those abbreviations mean? Left-hand limit and right-hand limit, exactly. Okay. Before I write the example down, let me talk about this. Piecewise functions can do one of 2 things. I'll use my pens as an example. You can have a piece here, you can have a piece there that they meet at the top or meet someplace. Or you could have a piece here and another piece there that they don't. This has a limit, that does not. So we need to figure out, without graphing it, if they do or not. Okay? So what we're going to do is we're going to write the function down first. F of x equals, draw up braces 2 lines. We're going to put 3x plus 1, comma, x is less than or equal to 1, x plus 3, comma, x is greater than 1. Now the question is going to say find the limit as x approaches. What number do you think that they're going to really be concerned about? 1, because 1 is where they break, if they break. All right. Now, according to the directions, we're supposed to look at from the left and the right. We can't solve this until we know the limit as x approaches 1 from the left and the limit as x approaches 1 from the right. So those 2 answers are going to tell me whether they connect or whether they don't. Okay. The problem is I'm supposed to plug it in. Which one do I plug it into? And it does matter, because sometimes there are going to be 3 pieces and you only use 2 of them. Okay? So let me show you the method that I've come up with to make this really simple and easy. Some of you may already know what to do, but just take a look at what I'm going to show you. This right here in the piecewise function is called a domain restriction. What is the definition of a domain? X values, because that's why it says X on it. A restriction means you can only use a certain part of it. So this is saying this graph is only being used for this part of the X's. This graph's only being used for that part of the X's. So what I'm going to do is I'm going to take the domain restriction and make it a little more simple. So come out to the side and draw a tiny little number line and put the 1 on it, because that's where it changes from one piece to the other. Okay? Now, come back over to the function and number the 2 pieces, piece 1 and piece 2. And I like to circle them to kind of define that it is not an exponent or a coefficient or something. Okay? So here's my question. This says x is less than or equal to 1. Which side of 1 are we talking about? The left side. Less than or equal to is over here. So put a 1 and circle it right there, because it says less than 1. Because all the numbers less than 1 are over here, correct? So that means the 2 is on this side. Agreed? Greater than 1? Which one is right at 1? 1 or 2?
1.
Why? Because it's equal to. Very good. Now, we're really not going to need this today, but we will down the road. So let's just start getting in the habit of doing that. Okay? So now the question says find the limit as x approaches 1 from the left. So here's 1. Here's left of 1. I plug into equation 1. It tells me quickly which equation to plug into. Do I need to say that again? Okay. It says 1 from the left. So I go to the 1. I go to the left side. Look up. First equation. So that says, oh, I'm supposed to plug 1 into the first equation. So 3 times 1 plus 1 is 4. There's my left-hand limit. Algebraically, I found my left-hand limit. So 1 from the right. Go to 1. The right. Go to the right. The equation is the second one. So I go.
Using 1 because that's where the limits.
That's where the function is defined. Yes. I'm only using 1 because the function is defined only on this side of 1. So this is basically telling me that the left side of the graph is equation 1 and the right side of the graph is equation 2. Okay? So 1 from the right means use this equation. So 1 plus 3 is 4 again. So does this have a limit?
Yes.
And it's 4. So do the pieces meet? Yes, they do. They do meet. Okay, any questions on that? That wasn't too hard, was it? Okay, I want to give you one to try. I'm going to put one up here and I'm going to walk around the room. I want you to work with your table and I want to check your work as you're doing it. So I need to go to a new sheet of paper. Is everybody done with this? Okay. Hang on. F of x equals x squared minus 2, comma, x is greater than 3. F of x equals the square root of x plus 6, comma, x is less than or equal to 3. I want to find the limit as x approaches 3 of the function. So I want you to do the limit from the left and the limit from the right. Okay. So go ahead and write that down. If the number line thing helps you, do it. And then plug the 2 in. It's very important that you get your left-hand limit and right-hand limit right, because there were several people who had them switched. The left-hand limit, when you do this, this is equation 2. This is that's 2 there and a 1 there. Most of you got that right, but then you come down here, you got to be sure. 3 from the left, so here's 3. Go left. That's equation 2. You should be plugging into the square root here. 3 plus 6, that's going to be 3. Ran out of room. 3 from the right, you're plugging in the other one. 3 squared minus 2 is 7. So the left-hand limit is 3. The right-hand limit is 7. Therefore, the limit here does not exist. Any questions? Okay, so now you know how to work with piecewise functions. We know how to direct substitute in just a regular function and a piecewise function. Now we need to start the conversation on what do you do if you plug in and you don't get an answer. Okay, so if direct substitution doesn't work, comma, you must find another method. And I'm going to start teaching you some of the other methods. I'm going to teach you one today. The video will teach you the rest. So if direct substitution doesn't work, you must find another method. Okay. For example, we're going to do the limit as x approaches -2 of x squared minus 4 over x plus 2. Okay. So that looks easy enough. Just plug in -2 and see what happens. But when you plug -2 into the top, what do you get?
0.
Okay. When you plug -2 into the bottom, what do you get?
0.
Oh, that's not good. Now, if the bottom had been something besides 0, if it had been 0 over 2 or 0 over -3, what would the answer have been? 0. The top is 0, it's 0. What if the bottom had been 0 and the top had been 2? That's undefined. And in limit terms, it's actually infinity. We'll talk about that later. But when it's both, what is it?
It's neither.
Okay, it is not 0. It is not undefined either. It is called indeterminate. And you need to know the difference between undefined and indeterminate. Undefined means there is no answer. Indeterminate means I can't find the answer yet. That sounds kind of weird. Okay? We got two rules at play right here. Rule number 1 says when 0 is on the top of a fraction, what's the answer? 0. Rule number 2 says anything over itself is what? 1. So put your pencils down for a second and just watch. Okay, so 0 over 0 is 0 according to rule number 1 that says 0 on top makes 0. 0 over 0 is 1 according to rule number 2. So which one is it? Well, I'm going to give you another fact here. 0 over 0 equals 99. It does. What? Really? Yes, it does. Let me show you why. Just watch me. Okay? Look at that fraction right there. 16 divided by 2. What does that equal? Because the answer times the denominator equals the numerator, right? Look over here. Does 0 times 0 equal 0? Yeah. Does 1 times 0 equal 0? Yeah. Does 99 times 0 equal 0? Yes. Does anything times 0 equal 0? Yes. So basically 0 over 0 could be any number. Okay? I'm about to show you. Now 1 over 0, a little freshman might think that this is what? They might think it's 1, but does 1 times 0 equal 1? No. Or they might think it's 0, but does 0 times 0 equal 1? No. Does anything times 0 equal 1? That's why it's undefined. Okay? Because nothing times 0 will ever equal 1. That's why it's undefined. Okay. Now the question is, since this can be anything, what is it? There's a way. I said 0 over 0 is something, but I don't know what it is yet. So, as far as we are concerned with limits, I want you to write this down. 0 over 0 equals keep going. That sounds like a strange answer. When you see a limit problem and you see 0 over 0, you need to keep going. Okay? So, how are we going to keep going? We're going to do some math to this problem and see if we can change it around and maybe get an answer. What can I do to the top of that fraction? Algebraically? I can factor it. And that's what I want to do. And I'm kind of hurrying because we're almost out of time. How does the top factor? X plus 2 and x minus 2. Does that help? Oh yeah, because what happens is the thing that caused the 0 on the bottom goes away. So now I just have the limit as x approaches negative 2 of x minus 2. Now can I plug in negative 2 and get an answer? So negative 2 minus 2 is negative 4. So in this case, 0 over 0 equals negative 4.
Yes.
Okay? We just found it.